Alright, so in this problem, I have phi to the power of x plus phi to the power of x is equal to 7. So the first thing I'm going to do is I'm going to factor out phi to the power of x from my left-hand side. So now I have phi to the power of, phi to the power of x times 1 plus 1 is equal to 7. 1 plus 1 is 2, so I have phi to the power of x times 2 is equal to 7. Now I can divide both sides by 2. So I get phi to the power of x is equal to 7 over 2. Now to solve this, I'm going to take the log on both sides. So I have log phi to the power of x is equal to log 7 over 2. And if I have something in the form log a to the power of b, I can actually move my exponent b here to the front, so I get b times log a. So in this case, I have log phi to the power of x, so I can move x to the front, and I get x times log 5 is equal to log 7 over 2. Now, if I have something in the form log a over b, this is equal to log a minus log b. So log 7 over 2, that's going to equal log 7 minus log 2. Now, I'm going to divide both sides by log 5. So then these two cancel out, and I get x is equal to log 7 minus log 2 over log 5. So log of 7 here, this is equal to 0.8451. Log 2, this is equal to 0.3010. And finally, log 5, this is equal to 0.6990. So now I'm going to have x is equal to log 7 minus log 2, so 0.8451 minus 0.3010, all over 0.6990, meaning x is equal to 0.5441. Alright, so in this problem, I have x to the power of x is equal to 4 to the power of x plus 16. So the first thing I'm going to do is I'm going to take the ln, or natural log, on both sides. So now I have ln x to the power of x is equal to ln of 4 to the power of x plus 16. Now if I have something, if I take the ln of something in the form a to the power b, and I can move this exponent b to the front. So this can equal b times ln a. So in this case, I have ln x to the power of x. I can move x to the front, and ln 4 to the power of x plus 16, I can move x plus 16 to the front. So now I have x times ln x is equal to x plus 16 times ln 4. Now if I distribute the ln 4, I get x times ln 4 plus 16 times ln 4. Now if I subtract x times ln 4 on both sides, these two cancel out, and I get x times ln x minus x times ln 4 is equal to 16 times ln 4. Now I can go ahead and factor out x from here, so I get x times ln x minus ln 4 is equal to 16 times ln 4. Now ln x minus ln 4, that's simply equal to ln x over 4. So I have this is equal to 16 times ln 4. And now this is essentially saying that x over 4 is equal to 4 over here. These two are equal to each other. So if x over 4 is equal to 4, this means that x is equal to 16, because these two have to match up as well. So now to check, let me plug this in over here. So if I plug in 16 over here, I get 16, because x over here, 16 times ln, 16 divided by 4 is 4. So I get 16 times ln 4 is equal to 16 times ln 4. So this works. Now for method 2, to check, I have x to the power of x equals 4 to the power of x plus 16. X equals 16, so I have 16 to the power of 16 is equal to 4 to the power of 32. 16 is 4 squared, so I have 4 squared to the power of 16 is equal to 4 to the power of 32, meaning 4 to the power of 32 is equal to 4 to the power of 32. Alright, so in this problem, I have x to the power of x is equal to 2 to the power of 2048. So to solve this problem, I obviously want to find the value of x. So for my solution, first start with x to the power of x is equal to 2 to the power of 2048. And now I'm going to rewrite 2048 here as 2 times 1024. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, a is 2, m is 2, and n is 1024. So if I rewrite this in this form, I get 2 to the power of 2 to the power of 1024. And remember, this is equal to x to the power of x. Now, 2 to the power of 2, that's equal to 4. So I have x to the power of x is equal to 4 to the power of 1024. Now, I'm going to repeat what I just did again. So 1024, that's equal to 2 times 512. So now I have x to the power of x is equal to 4 to the power of 2 times 512. And again, this is equal to x to the power of x is equal to 4 to the power of 2 to the power of 512. 4 to the power of 2 is 16. So I have x to the power of x is equal to 16 to the power of 512. Now 512 I can rewrite as 256 times 2. So I have x to the power of x is equal to 16 to the power of 2 times 256. Now this, I'm going to do the same thing again. So I have 16 to the power of 2 to the power of 256. And 16 to the power of 2, that's equal to 256. So now I have x to the power of x is equal to 256 to the power of 256. And if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, x is equal to 256. And to test this, I'm going to plug this in. So I have 256 in for x. So I have 256 to the power of 256 is equal to 2 to the power of 2048. And remember, we just wrote all of this, so we know that 2 to the power of 2048 is equal to 2 to the power of 2048. Alright, so in this video, I'm going to solve the problem 3111 squared plus 2889 squared. So to solve this, I'm going to rewrite this as 3000 plus 111 squared plus 3000 minus 111 squared. Now if I have something in the form a plus b squared, this is equal to a squared plus 2ab plus b squared. And if I have something in the form a minus b squared, this is equal to a squared minus 2ab plus b squared. So 3000 plus 111 squared is equal to 3000 squared plus 2 times 3000 times 111 plus 111 squared. And now I have this plus 3000 squared minus 2 times 3000 times 111 plus 111 squared. So these two, negative 2 times 3000 times 111 and positive 2 times 3000 times 111 cancel out. So I'm left with 3000 squared plus 3000 squared plus 111 squared plus 111 squared, which is the same thing as 2 times 3000 squared plus 2 times 111 squared. So now if I factor out 2, I get 2 times 3000 squared plus 111 squared. Now 3000 squared is equal to 9 million. And 111 squared, we can actually solve this right here. 111 times 111 it's 12321. So I have 2 times 9 million plus 12321, which is just 2 times 9,012,321. So 2 times this is going to be 18,024,642. So this is my solution to this problem. Now, if you haven't already, please make sure to leave a like, subscribe, and share this video. Thank you. Bye-bye.